Hello everyone. Welcome back to the AWS Certified Solution Architect Associate Certification Bootcamp. In this module, we'll cover everything you need to know about Application Load Balancer or ALB to succeed in the AWS Certified Solution Architect Associate exam. We'll start with Application Load Balancer features, then we'll review content-based routing and we'll review host-based, path-based, query string and header-based routing. Then we'll discuss target groups and health checks, followed by we'll review slow start feature, then sticky session or session affinity feature, followed by TLS offloading and mutual TLS. Then we'll review server name indication or SNI, followed by fixed response and redirects, then automated target weights. Before concluding the video, we'll review X-forwarded port and headers. We have a lot to cover and I promise this is going to be a very informative session. So let's get started. Application Load Balancer operates at layer 7 or OSI layer 7, which is application layer, and it can work with HTTP and HTTPS traffic. ALB can route the traffic based on request content. That is why Application Load Balancer can be used in containerized, microservice, and serverless environments. Let's review what is content-based routing. Content-based routing allows the Application Load Balancer to make intelligent decisions about where to send incoming traffic based on the content of the HTTP or HTTPS request. This includes host-based routing, port-based routing, query string-based routing, or header-based routing. We are going to review all the different types of routing in consecutive slides. Application Load Balancer evaluates the request attributes and forward traffic to the most appropriate target group. Now you must be asking, why should we use content-based routing? Content-based routing will help you to reduce the number of load balancers by handling multiple applications behind a single application load balancer. You can also support microservice architecture by directing requests based on the service-specific paths, and you can also deliver personalized user experience, like if you would like to show mobile optimized pages, then Application Load Balancer is the best fit for that. Now let's review content-based routing one by one. We'll start with host-based routing. Under host-based routing, Application Load Balancer route traffics based on the domain name. As a use case, you can host multiple subdomains or application modules using the same Application Load Balancer. Let's understand with an example. Let's assume for your regular users, your application domain name is user.cloudexpertsolution.com and you have a backend microservice maybe hosted in EC2 to serve that feature or to serve the regular users. You also have a module to handle admin users, and admin users can access all the administrative features using admin.cloudexpertsolutions.com. Now if you have an application load balancer in front of both the microservices, when request will come from the regular users, that is with the domain name user.cloudexpertsolution.com, then application load balancer will be able to route the traffic to the user microservice. On the other hand, if an admin user logs to the application or they will try to access the admin page, then Application Load Balancer will be able to understand that request and it will route the traffic to the microservice which is built for the admin features. Next, let's review path-based routing. Under path-based routing, Application Load Balancer routes traffic based on URL path. This is useful for microservice architecture where each service handles a different URL. Let's understand with an example. Let's imagine to optimize latency, you have segregated static component and the dynamic component of your web application, and you are hosting all the static components in a separate microservice or maybe in a separate server, and you are using cloudexpertsolution.com/image to serve the static content, whereas you have dynamic contents where you are serving all the API requests and you are using a separate microservice to host those APIs or backend APIs. You have one application load balancer front-ending both the microservices. Now when user will request for /images, or if there is a request to retrieve some image file or static file, then application load balancer will forward the request to the backend which will serve the images. On the other hand, if there is a request for a dynamic content which will be served via API and the request is coming with an URL/API, application load balancer will forward that request to the backend which is responsible for the service APIs. Instead of serving the content from one EC2 instance, you can have multiple servers serving the content, and you can have auto scaling group to automatically scale out or scale in based on the request. These groups of backends is called target groups. For image services, it's called image services target group, and the target group which is serving the backend API services, it's called API service target group. Now let's review target group. Target groups are logical group of servers or backend targets where application load balancer can route traffic. This includes EC2 instance. You can have one single EC2 or a pool of EC2 instance managed by autoscaling group. You can also have Amazon ECS or AWS Fargate task. We haven't covered ECS and Fargate yet. ECS is Amazon's managed containerized platform to host Docker containers, and Fargate is AWS's serverless offering to host Docker or Kubernetes containers. You can also have AWS Lambda as the target group. AWS Lambda is AWS's serverless compute offering, or even you can have a private IP address as the target group. For every target group, you need to create a listener rule to forward the traffic. You can also enable health check at the target group level. Using the health check, application load balancer can isolate any unhealthy instance or services in a target group, and it will route traffic only to the healthy instance. We will review health check and we have a dedicated slide. But before that, let's review other content-based routing, and now we will review query string-based routing. If you are not familiar with what is query string parameter, let me explain with an example. Query string parameter is a way to send extra information to a website through the URL. It comes after the question mark. In a URL, if you see anything after the question mark, those are the query string parameter. If a URL looks like this, then in this example, query equal to pen and color equal to blue, these are two query string parameter. Now you can configure application load balancer to route traffic based on the query parameters in the URL. This is ideal for e-commerce platform or APIs that need to filter traffic based on the URL parameters. Now let's understand with an example, and let's imagine you have two separate microservices to handle product search and checkout feature in your e-commerce application. Any incoming traffic with product search request with a query string parameter like service equal to search, application load balancer will route the traffic to product search target group. On the other hand, if you have user traffic with checkout, that is the traffic with service equal to checkout query string parameter, then application load balancer will route the traffic to checkout target group. Next, header based routing. You can set up your application load balancer to look for specific HTTP headers and route traffic based on the HTTP headers in the request. You can also set up routing for custom HTTP headers. Header-based routing is great for A/B testing or providing mobile versus desktop experience or setting up routing based on the environment. Let's understand with an example. In your web application, regular production traffic comes with no specific HTTP header, and you have a target group to handle existing production workload. You also have some beta feature and you want to test those beta features, and you have a separate target group where the beta features are deployed. Any beta testing traffic will come with an HTTP header called X environment equal to beta. And you also have mobile users in your application, and to improve the user experience, mobile optimized pages are deployed to a separate target group. Now mobile traffic will use user agent equal to mobile as the HTTP header, and you have deployed an application load balancer in front of all these target groups. Now when the regular production traffic will come, it will have no specific HTTP header. Application load balancer will route the traffic to the production target group. Once you have beta testing workload, that means the beta tester with a specific header as X environment equal to beta, application load balancer will route the beta traffic to the beta feature target group. And on the other hand, if you have mobile users with a specific HTTP header user agent equal to mobile, then application load balancer will be able to route the mobile traffic to mobile optimized backend. For the AWS certification, please remember content-based routing is only for layer 7 or for application layers capability, and it is only supported by application load balancer. And please remember, classic load balancer or network load balancer or gateway load balancer does not support this content-based routing. Now let's review load balancer health check. Health check is a way for the application load balancer to automatically monitor the health of targets like EC2 instance or container in a target group. If a target fails the health check, application load balancer stops sending traffic to it until it becomes healthy again. You must be thinking, how does it work? Let's assume you have 3 EC2 instances behind an application load balancer and you have configured health check with a path set to /health, protocol HTTP and port 80. Now application load balancer will periodically send request to specific path, that is /health for our case, on each target. For our example, it will be EC2 instances, and based on the response, it determines if the target is healthy or unhealthy. Application load balancer will send traffic only to the healthy instances, and let's assume that instance 2 stop responding or returns 500 error. Then ALB will mark instance 2 as unhealthy, and ALB will stop routing traffic to that unhealthy instance, and rather it will route traffic to the nearest healthy instance. Once the instance passes the required number of successful checks again, it will be marked as healthy and traffic will be resumed. Now please remember, if you are using HTTPS for health check, you need to make sure the certificate is valid. Otherwise, your health check will fail even if the server is up and running. Now let's review a different feature of application load balancer, which is slow start and traffic warm up. Slow start mode is a feature designed to prevent newly registered or re-registered target from being overwhelmed with a sudden influx of requests. Let's assume that you are launching a new EC2 instance behind your application load balancer. Now instead of flooding it with requests, application load balancer slowly increases the load so that server can warm up. This is perfect for application that initializes caches or load data at startup, and you can configure the slow start duration and you can keep the value between 30 seconds to 900 seconds. Now let's review another one application load balancer feature called sticky session or session affinity. Sticky session enables the application load balancer to route all requests from a particular client to the same target or EC2 instance or backend server for the duration of session. Let's assume we have a stateful web application and a user authenticated himself or herself with a specific target group. After the authentication, it established an authenticated session with the target. Now, without a sticky session, the user might get routed to another one instance which does not have any information about the previous authentication. And in that case, user will be forced to authenticate or log in again, and user can see login pop-up, which is very annoying for the user. As a solution, you can enable sticky session on a target group. When you will enable sticky session, application load balancer will send the initial request to any healthy target. It will insert a cookie in the response, and then for all subsequent requests with that cookie, the application load balancer always routes the traffic to the same target instance, as long as the target instance is healthy and it is within the session timeout. You can configure the duration in seconds. That means for how long the session stickiness should last. Sticky session is not ideal if you have a stateless application or if you have a stateful application but you are already using a centralized session management system. In that case, you should not enable sticky session. Now let's review Application Load Balancer Security Group. In our previous session, we talked about how our user could access to the web application that is hosted on an EC2 instance using the public IP. But here is the thing. We also review the public IP will change every time when you restart the EC2 instance. So to avoid any IP change, we have used elastic IP. Now for the user to access that EC2 instance, we reviewed that we need a security group, and in that security group, we need to add one inbound rule. In that inbound rule, you are specifying the port as 80 or 443. If your traffic protocol is HTTP, then you should use 80. If it is HTTPS, you should use 443 port. And in the source, we have used 0.0.0/0. That means we allowed wide open and any traffic from internet to reach to our EC2 instance, which is not a security based practice because AWS recommends production applications should not have direct exposure to internet. To avoid this, you can configure one application load balancer in front of your EC2 instance. Now user will access application load balancer and application load balancer will forward the request to the backend EC2 instance. Now application load balancer also comes with a security group. It's called Application Load Balancer Security Group or ALB Security Group. For user to access application load balancer, you again need one inbound rule similar to whatever we had for the EC2 instance. That means we need to allow traffic on port 80 or 443. Protocol should be HTTP or HTTPS and the source should be anywhere from internet. Now since you have one application load balancer which is intercepting all the incoming requests, now you can update the inbound rule of your EC2 instance and you can replace the source from anywhere to application load balancer security group. With that, you are adding security to your EC2 instance and you are avoiding your EC2 instance to be exposed anywhere in the internet. Now if any direct traffic from the user will try to reach to the EC2 instance with the EC2 instance public IP, that traffic will be blocked and user will not be able to reach EC2 instance directly. That is why we no longer need that elastic public IP, and even you can eliminate the default public IP address of the EC2 instance and you can launch that instance with only a private IP. Please remember, this is the security based practice, and when you are configuring application load balancer in front of your target group, you should only allow traffic from the application load balancer security group. Next, we are going to review TLS offboarding and mutual TLS. You must be asking, what is TLS? TLS is transport layer security. This is the encryption protocol behind HTTPS and it secures data between a client or a browser and a server. Let's assume our user's laptop is the client and our client is trying to access our web application which is exposed via HTTPS. Without TLS offloading, user's browser will send an HTTPS request to the web server. That means the request will be encrypted. Now the web server decrypts the request using its certificate. Then the web server will generate the response and it will encrypt the response, and after that it will forward the encrypted or HTTPS response to the client. This entire process will increase the CPU load on the backend EC2 instance because you have to handle the TLS processing, the encryption and the decryption process. Now to eliminate this, application load balancer offers TLS offloading. TLS offloading means the application load balancer handles the TLS handshake and the encryption decryption, and your backend EC2 instance does not have to perform all those encryption decryption steps. Now let's review the process with TLS offloading. That means your application is behind an application load balancer. Now the user's browser sends an HTTPS request. That means the request will be encrypted. The application load balancer decrypts the request using its certificate. Application load balancer then forward the unencrypted traffic or HTTP request to the backend EC2 instance over a private connection. EC2 will generate the response and it will forward the unencrypted or HTTP traffic back to application load balancer. Then application load balancer will encrypt the response and it will forward the encrypted or HTTPS response to the client. With TLS offloading, you can reduce CPU load on your backend EC2 instances because now EC2 instances don't have to handle the TLS processing, and it will also simplify the certificate management. You can upload your SSL or TLS certificate to AWS Certificate Manager and you can attach them to your ALB listener. TLS offloading will also help enforce secure HTTPS communication without even touching your application servers. Since we have reviewed TLS and TLS offboarding, now let's understand what is mutual TLS or MTLS. Mutual TLS goes one step further than regular TLS. In normal TLS, only the client verifies the server's identity via its certificate. In mutual TLS, both client and the server verify each other's identity via their own certificate. And why should we use mutual TLS? Because this is great for zero trust architecture or for B2B APIs. It will also ensure that only trusted client can access your application. Now let's review server name indication or SNI. Server name indication enables the application load balancer to host multiple SSL or TLS certificates on a single listener. Let's understand why we need SNI. In the previous slide, while explaining host-based routing, we explained how ALB can distribute traffic based on domain name, or you can serve multiple websites using a single ALB. But things get little complicated when you host multiple HTTPS websites. That time you need to configure TLS listener on port 443 for both your target groups. During a TLS handshake, the server presents its SSL or TLS certificate before knowing which host name the client is trying to access. Without SNI, you can only serve one certificate per listener per port. However, you need to host multiple TLS, one for each domain on the same listener port, that is 443, to support host-based routing. Now with SNI, the application load balancer can host multiple HTTPS websites on the same load balancer, and it will save cost by using one application load balancer for multiple HTTPS applications or domain and maintain each site's SSL or TLS certificate separately. SNI also allows the application load balancer to inspect the host name and serve the correct certificate during the TLS handshake, then route the traffic to the correct backend. During the AWS certification, if a question asks how to host multiple HTTPS application or domain on the same ALB, then the answer will be SNI on application load balancer. Now let's review application load balancer fixed responses. With fixed response configuration on ALB, you can respond to any HTTP request without sending the traffic to a backend or to a target group. And ALB responds immediately with a fixed HTTP status code, message and content type. As a use case, you can return a custom message when a route is under maintenance. You can also respond with 403 forbidden if the path is restricted. And you can also handle API depreciation notice. That means if that API version is no longer supported. Now let's understand with an example. In our previous slide, while explaining path-based routing, we reviewed ALB can route traffic based on URL path. Now here we have path for /image and /API. Now you can define a new rule, and if the request path is /beta, you want to respond those requests with a status code as 503, and the message could be service under maintenance, try again later, or any custom message you want. Now when a user invokes that URL with /beta, The application load balancer will return the response directly without even invoking any target group or the EC2 instances for our case. Now there is another one concept called redirect. The ALB can redirect the client to a different URL. It could be same or new host, path, protocol, or even port. This is a client-side redirect, meaning the browser is told to make a new request. As an use case, you can implement HTTP to HTTPS redirection, or if you want to implement force secure connection, you can also redirect from old to new domain, or if you want to implement URL normalization, then you can use AWS redirect feature. Now let's review another one ALB feature called automatic target weights. With automatic target weight, you can implement fine gain traffic control, and you can distribute traffic unevenly between the target groups. If you have two target groups, you can send 90% of the traffic to one target group and the remaining 10% to the another one target group. As an use case, you can use when you want to test new version of your application. Now let's understand with a diagram. Let's assume that you have two different versions of your application, and new version is version 2, while the application version 1 still it is running. Instead of exposing the version 2 directly to production traffic, you want to test this new version with a live production traffic. Then you can configure the target weights, and you can configure the target group with a weight. That means 90% of the traffic will come to application version 1 target group, and the remaining 10% will go to version 2. Based on that, majority of the traffic will come to application version 1 and only 10% will be redirected to the application version 2. You can also monitor the performance, and now if you are seeing your new version or the version 2 is working as expected, you can gradually switch the traffic from 10% you can increase to 20% and all, and this is called blue-green deployment, or you can use this technique for A/B testing. Last but not least, let's review X forwarded port and headers. Let's imagine a user opens https://cloudexpertsolution.com/login, this URL in their browser. Then the web browser will make a HTTPS request on port 443. The application load balancer will receive the request. It will terminate the SSL and it will forward it to the target group on port 80. When your backend servers will receive the traffic from application load balancer, it will see the application load balancer's internal IP and port, not the original client's IP, port or protocol. But if you have an use case and you want to know the real IP of the client for audit, maybe for rate limiting or maybe for geolocation, or if you want to know the protocol which is used by the client, is it sending using HTTP or HTTPS, or if you have a use case to know the port the client used to connect the application load balancer. To support all these use cases, application load balancer adds special header to preserve information about the original client's request, and these headers are X forwarded for, which will have the client's IP address, X forwarded proto, which will have the client's protocol, and the X forwarded port, which will have the client's port. Now let's map with our use cases. For the first use case, if you want to know the real IP for audit or rate limiting, you can use X forwarded for. If you want to know the protocol used by the client, you can use X forwarded proto. And if you want to know the port the client used, you can use X forwarded port. These are known as X forwarded headers, and these headers are critical for logging, debugging, and any application logic where you need to access the client's original IP, port, or protocol. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at Cloud Expert Solutions. You are now one step closer to crushing your exam. See you in the next module.